Mic test, mic test. Alright, this is my MPPR final assignment with bullet hell. My group decided to do bullet hell, and we did 4 levels each. So let's dive into the math part. So since I had time, I made my level more interactable, but that's not part of it. So here is my first math logic. In this scene, I have two kinds of bullets, one that goes in a spiral, one that goes in a circle. I'll show it here. As you can see, there's two, one spiral, one circle. So when there's a boss that doesn't shoot, and there's the player which can also shoot. I'll show it right here. As you can see, it's like that. So let's dive into the scripts. These two are for aesthetic purposes to change for the other scenes since I added cutscenes. So let's go to player bullet first. So in player bullet, uh, the math part is only here where I introduce speed. So update most constant variable edit. So that each bullet has lifetime of 6 seconds. So the math portion is only here when it goes to get distance, right? This method, right, it calculates the distance between 2 points, and then it uses Pythagoras theorem to find the distance, and it returns the Euclidean distance between the 2 points using Pythagoras theorem. Then moving on to bullets. The bullets logic is for enemy. So for bullets, they just is speed. There's also this where it uses waves. So for bullet, right, it initializes bezel movement, and then it has to start. So basically, this is for since wave has frequency and amplitude, that's why it's wave. So the bullet logic is use time elapsed plus time delta time, and then applies wave offset, which is based off the sine and cosine rule. Use custom sine for this. Then I added perpendicular direction to calculate the wave effect in the direction I want it to go. So in this case, I added it so that there's like the vector new direction y, direction x. So over here, new offset is the curve position, and then this part basically moves the bullet from straight line direction based on the direction and speed. Then it applies to the bullet, cause the bullet to move in the curve path. Collision check using player tag. So I use player tag since I can't use collider. So yeah, I think that's pretty much it. Oh, over here, I use Euclidean distance between the 2 points to get in the 3D space. This is for collision detection. I use math square root, which is basically Pythagoras theorem. And I normalize over here to get the length of 1 to ensure the bullet's movement is consistent regardless of the direction I wanted to input. Then the magnitude of the speed, basically, using math square root again. And then finally, I use the Taylor series expansion, which basically approximates the sine value. So yeah, it's roughly like Unity's built-in sine, but the one is more accurate. So moving on, player. There's not much math to this. It's just over here. I use clam. That's about it. Then I just put a player tag. Moving on, level 2. After the cutscene, level 2. This is a new kind of. I implemented 2 new functions. One is shield. One is another kind of a bullet. Let's play. As you can see, there's shield and there's DVD bullet. Let's go to DVD bullet first. So in DVD bullet, right? I base it off like the DVD where it bounces from a screen based on the screen size. So this one is using orthographic camera size. Time lapse, keep track the time a bullet has been alive. So on check bounce, the math part is over here during check bounce, where it does the horizontal boundaries over here, and then if the bullet's X position is outside screen bounds, then the X will be reverse multiplied by -1 over here, and then it's clear with the X bounds. And then after that, similarly for vertical, right, it basically does the same thing, but for the Y position outside, it just reverse it. So that's pretty much it for the bullet logic. This one is collision, using play attack. This one is shield tag. Then there's a get distance. This one is similar to the other bullet logics where it uses Elutian distance between the 2 points, and then after that, normalizing the vector. To after that, you normalize makes the vector unit 1, and then ensures the bullet's moving speed is correct after expecting the speed. So the magnitude of the line is just vector. Yeah, that's the math square root over here. The value is minimum returns min. Yeah, over here basically just logic check based on the previous bullets too, or similar. Let's move on to the player shield. So player shield over here, there's not much to it. It's just rotate active shield. When shield is active, you can also rotate the shield. Then also the array of game objects. After that, the boolean shield active. Yeah. So the math logic is actually the sum here. When shield is active, right? Basically, set the true, and then after that, for each shield, right? Let's do in this case, the method calculates based on the position of the evenly spaced angle, and then after that divide by 180, and then after that it subcount -1 in the case where it's bullet. There's increments over here. So after that the shield are instantiated using this instantiate. Then yeah, there's also the cooldown too, but that's not math. Over here rotating shield, that's another math part where uh basically, right, this method, right, makes the shield revolve around the player. Shield count -1. The angle is converted to radians, and the x and y coordinates are calculated using cosine and sine respectively. This one basically the position is updated by the settings to calculate the x and y values relative to the player. And it keeps on revolving around the player. And that's pretty much it. Calculate shield position, yeah. Let's calculate shield position for it's just also using cosine and sine and calculate player position. Yeah, that's it. I think that's all the math parts. Okay. Yeah. The entire game is playable. Yeah, I think that's pretty much it. Thank you.